All right, welcome back. Today we're going to do the very last section of Chapter 9, and that's Chapter 9, Section 9, and it is the quadratic formula. This whole beastly thing explains how the quadratic formula was derived using completing the square. So if you want to attempt to understand this, the first step of completing the square is to get the x squared alone. So everything's going to be divided by a. The second step is to set it equal to 0 because we're going to figure out where the two x-intercepts are. Once it's equal to 0, we're going to bring this over and figure out what we need to add so that we can complete the square. Now that we have that, we know our perfect square is right here in red. And when you take the square root of both sides, it simplifies down to this. And tomorrow I'll play a song for you to help this become memorized. You might have it memorized by the time you get here. But it's negative b plus or minus square root b squared minus 4ac divided by 2a. So we're going to essentially use that formula to now find the two zeros, the two x-intercepts. And what's neat about this is negative b over 2a. If you remember that, that's your line of symmetry. That's where it appears. And then I'm going to erase that. So our first equation, we have everything on one side. A is equal to 2, B is equal to 3, and C is equal to negative 5. So negative b plus or minus square root b squared minus 4ac divided by 2a. And then we start to simplify. So negative 3 plus or minus square root of 9 plus 5 times 2 is 10 times 4 is 40. It's plus because of the minus a negative. And then divided by 4. So we have negative 3 plus or minus the square root of 49 is 7 divided by 4. So that means we have negative 3 plus 7 over 4, and we also have negative 3 minus 7 over 4. So 4 over 4 is 1, and negative 10 over 4 is negative 2.5. So what this tells us is if you look at a graph, our two zeros are at 1 and at negative 2.5. Therefore, the line of symmetry is directly in the middle. You could find other points and plot that, but these are two ordered pairs. 1 gives you 0, and negative 2.5 gives you 0. So let's do another. Going back up. I'm going to set this equal to 0 first. So we'll go ahead and subtract 2x. So 0 equals x squared minus 2x minus 3. Therefore, a is 1, b is negative 2, and c is negative 3. So we have negative b, so that would be positive 2. Opposite of the negative is a positive. Plus or minus square root b squared, put that in parentheses because it's going to be a positive, minus 4ac divided by 2a. So 2 plus or minus square root of 4 plus 12 all over 2. So 2 plus or minus the square root of 16 is 4 all over 2. So that's 2 plus 4 over 2 and 2 minus 4 over 2. So this solution would be 6 divided by 2, which is 3. And this solution is negative 2 divided by 2, which is negative 1. So those are those two x-intercepts. And the last one over here, A is 1, B is 3, C is negative 7. So negative B plus or minus square root B squared minus 4AC divided by 2A. Whoa, 1. Okay, so negative 3 plus or minus square root of 9, another plus, because minus a negative, and that's 28, divided by 2. So negative 3 plus or minus square root 36 divided by 2. That's negative 3 plus 6 over 2 and negative 3 minus 6 over 2. So 3 halves is 1 1/2, and negative 9 halves is negative 4 1/2. So those are our two zeros, our two x-intercepts. So far, everything's been perfectly factorable. Try a couple more. So, A is 2, B is negative 8, and C is 10. Negative B plus or minus square root B squared minus 4AC divided by 2A. So 8 plus or minus 64 minus 80 divided by 4. Now, under the square root, this time we have a negative because 64 minus 80 is negative 16. So what this means is that there are no x-intercepts. This graph is going to be floating up here somehow, somewhere. It's never going to cross the x-axis. So there are no solutions for the x. It looks like this, exactly. Go down. Okay. You could figure that out by doing negative b over 2a to find the vertex, plug it in and solve, and put in a couple more points. Okay, the next one. Let's go ahead and move everything over to the right. So we have 0 equals 3x squared minus 6x plus 3. So A is 3, B is negative 6, and C is 3. So negative B plus or minus square root B squared minus 4AC divided by 2A. So 6 plus or minus square root of 36 minus 3 times 3 is 9, and 9 times 4 is 36. So this times under the square root we get a 0. So we only have one x-intercept, and that would be 1. So our graph would touch the axis only once. That would also be the vertex because there's only one x-intercept. This is a graph of it opening downward because of you could either move the 3 back and make it open downward. You could also do this exact same graph that I did, making it go upward. And it would be the exact same thing, just flipped. This is still the vertex, but this would go up. So both solutions are fine because you're setting it equal to 0. So there's three different possibilities here that you're going to get when you do the quadratic formula. You're going to either get something with two solutions. That would mean the plus or minus b squared minus 4ac is positive. You're going to get something with one solution, and that would mean that the square root of b squared minus 4ac is 0. Or you're going to get no solution for the x-intercept quadratic formula. And in that case, the square root of b squared minus 4ac is negative, and you cannot take the square root of a negative, so that's why it looks like that. Which is what I just explained. All right, so we're not going to find the whole quadratic formula. We're just going to tell how many solutions it has. So all we're going to look at is the square root of b squared minus 4ac. So in this case, we have a is 3, b is negative 2, and c is 2. So b squared minus 4ac. We're not going to worry about the rest. We're just figuring out how many solutions. So we have 4 minus 4 times 3 is 12, times 2 is 24. So we have a negative under the square root. This one has no solutions. It does not cross the x-axis. In the next problem, our a is 2, b is 11, and c is 12. So again, we're just going to look at the thing called the discriminant, that stuff under the square root, to see how many solutions there are. So b squared minus 4 times a times c so 11 squared is 121. And then 4 times 2 is 8, and 8 times 12 is 96. Under the square root, we have a positive number, so we have two solutions, two x-intercepts. And letter C. A is 1/2, B is negative 4, and C is 8. B squared minus 4ac. So we have negative 4 squared minus 4 times 1/2 times 8. So we have 16 minus 16, which is 0. So we have one solution, because the square root of 0 means that you're not going to add or subtract anything. So we have multiple different ways to figure things out. If you look at this lovely table, graphing, a good way to approximate zeros but not get the exact answer. Factoring, if it's factorable, it's great. If not, you can't factor. Square roots, if you can easily solve for x and something is square rootable, that's a great method. If not, not going to work. Completing the square will always work. Sometimes it's a little bit difficult, but it's a good way to solve. And then using the quadratic formula is very easy to make a mistake. You can always find the exact answer, but other methods might be easier. So in the first one, this is factorable. It's x plus 2, x plus 3. So factoring would be the best method to solve this. Your two zeros would be at negative 2 and negative 3. Your line of symmetry would be right in the middle at negative 2.5. Plug that in, get your answer. You should be getting a smile because it's a positive x squared. This, you can easily isolate the x squared. So the easiest method for this would be taking the square root of both sides. 12 isn't a perfect square root, but it's the easiest. I would just put the square root of 12 plus or minus. If you want the square root, it is 3.4641 more, but it's a rounding error, so this would be your best answer, plus or minus square root of 12. We again have something that's factorable. 2 times 12 is 24. So what two numbers multiply to give you 24 that add to give you 11? And that's 8 and 3. So if you draw your box, you have your 2x squared, your 12, your 8x, and your 3x. We've got to fill in these missing numbers. I'll color code this slightly. So this is going to have to be your 2x. This is going to be your x. Oh boy. And then in 12, this would have to be your 3, because that's a 3. And this is your x, which means this would have to be your 4, because this is your 2x, and everything works out. So your factored form is 2x plus 3, x plus 4. Just a quick recap. The 0 here is negative 4. To find this 0, you need to solve a mini problem. So you're going to subtract 3 from both sides and then divide by 2. So negative 3 halves is our other 0. You could also do that with the quadratic formula. You could do that by completing the square. Anything is great. This one's set up for completing the square. So half of 6 is 3. So on the left here, we're trying to figure out how to make it an x plus 3 squared, which means we're going to have to add 9 to both sides. So x plus 3 squared equals 2, and then you square root both sides. So x plus 3 will equal plus or minus square root of 2. So x will equal negative 3 plus or minus square root of 2. You can leave it just like that. You could get the 2 decimals. All right, a little extra practice. We'll do a few of these. We're going to just keep going on the quadratic formula. So negative, well, a is 1, b is negative 9, and c is 7. It's not factorable for sure. No two numbers multiply to give you 7. So we've got negative b plus or minus square root b squared minus 4ac divided by 2a. So 9 plus or minus 81 minus 28 all over 2. Whoops. So 81 minus 28 is 53. The square root of 53 is some funky decimal. So our answer could just be written like this, or you could actually do 9 plus 7.28 divided by 2 and 9 minus 7.28 divided by 2, which I'm not going to find the decimals. I prefer this because there's no rounding error, but if you did need to actually plot it out, you would find those 2 decimals and graph it. All right, letter B. I really like positive x squareds. I'll just move the 1, but you could also move everything over to the other side. Doesn't matter which way. You'll get the exact same answer for the x-intercepts. So a is negative 3, b is 5, and c is negative 1. So negative b plus or minus square root b squared minus 4ac divided by 2a. So negative 5 plus or minus square root of 25 minus 12 all over negative 6. So that's negative 5 plus or minus square root of 13 all over negative 6. Again, this is a fine answer to leave it like that. You could do the square root of 13 and get 3.6055. So you could find your two decimals by negative 5 plus 3.605 divided by negative 6, and negative 5 minus 3.605 divided by negative 6, but it's not necessary. Letter C. A is 5, B is negative 10, C is negative 8. Negative B, plus or minus square root b squared minus 4ac divided by 2a. So 10 plus or minus 100 plus 4 times 5 is 20. 20 times 8 is 160 divided by 10. So that's 10 plus or minus square root of 260 divided by 10. So the square root of 260 is 16.12. Again, this is a totally fine answer. You could go through and solve 10 plus 16.1245 divided by 10 and 10 minus 16.1245 divided by 10, or you can just leave it. And last, A is 8, B is negative 13, and C is negative 6. Negative B, plus or minus square root b squared minus 4ac divided by 2a. So 13 plus or minus square root of 169 minus 4 times 8 times 6 is 192. It's actually a plus because of the two negatives. All over 2 times 8, which is 16. So 169 plus 192 is 361. So 13 plus or minus square root of 361 divided by 16. The square root of 361 is 19. So in this case, we should simplify because it's simplifiable. So 19 plus 13 is 32, and 32 divided by 16 is 2. And then 13 minus 19 is negative 6, and negative 6 divided by 16, we should reduce that. Take a 2 out of both, negative 3 over 8. And that is the quadratic formula. I'll write it one more time. Negative b plus or minus square root b squared minus 4ac divided by 2a. And a catchy song tomorrow to hopefully make you remember that and get excited.